Hello, guys. This is Team 15. My teammates are Diego Garcia Tovar and Eric Barragan, and myself, Luis Moreno. And our video is going to be about vehicle fleet management. To begin, I'll be explaining the problem. The problem is that we're going to have three different vehicles to be specific, which will have to transport entities from one location, a source, to another destination, which will be a sink. There are some assumptions. The first assumption is that vehicles are going to pick up the entities, and the entities do have to wait in the location until they are picked up, and then transported by the vehicle to be dropped off at the sink. The other assumption is that the trucks, the vehicles have to drop off the entities in a specific location. So, for example, truck one is going to be designated to sink one. It could only drop off entities in sink one, which in this case it'll read as input at sink one. Truck two can only drop off entities in sink two, and so on and so on.
Okay, so before we move on to the Simio model, we're gonna briefly explain some of the objects and the processes that we're gonna be working with. So of course, the most important one is the vehicle. A vehicle object may be used to transport entities between node locations, and we're gonna be creating an on-demand routing type vehicle that will be used as a movable resource that is seized and released for non-transport related tasks by model process logic. We're also gonna have a truck fleet management process logic, which will be invoked whenever a new ride pickup request occurs or an entity is unloaded. And finally, the math epsilon, which is a delay that forces the fleet management decision making to occur as a late event. So now we're gonna move on to the Simio model. Okay.
Okay, so to begin, we are going to begin with placing three sources. Okay, and then the next step is to place three sinks aligned with the corresponding source. And now we're gonna press the control key and then click on each source so that we could click all of them. And we're gonna go ahead and change the inner arrival time to random exponential 0.5. And the units are still gonna be minutes. Okay, so this is gonna be the basic setup. Now we have to define a vehicle. Under the library, we could see an icon for a vehicle. We're just gonna click and drag and place it anywhere on the map. And then from here, we're gonna click on the name and then change the name from vehicle one to truck. From here, we're gonna go to the properties table. We're gonna go down to population. And then under population, we're gonna change the initial number in system to 3. This way we don't have to create 3 different trucks. We just have that one truck, and then later on we'll define the other 2 based on this one. From here, we are gonna go ahead and we're gonna click on the vehicle and then go to the attached animation ribbon on the top and then click status label. After we click status label, we're gonna place the status label right above the vehicle. As you can see on the right-hand side on the properties, it is attached to the truck. And under expressions, we're gonna write the following expression. In quotations, it'll be truck hashtag, close the quotations, and then it's gonna be a plus sign, string, dot, from real, parentheses population.index. What this is going to do is that it's going to assign a number to the truck. It's going to aid to assign a number to the truck, and this is why we don't have to have 3 different trucks. So we're going to follow to the next step, which is defining the entity. So to define the entity, we are going to go down on the navigation window and click on model entity. And then go to the and then go to the I'm so sorry. Go to the definitions window. And then in the definitions window, we're going to hit the states panel, and we're going to add a new state variable. Under objective references, there is going to be a tab that says transporter, and that is the one we have to select. And then from this, we're going to change the name to assigned truck. This later on will be used to reference the model entity. So we will use, for example, model entity dot assigned truck. This is how it'll be referenced. And now we're going to go back to the facilities window, go back to the model under navigation. And then under the facility, we are going to place a model entity. And then the model entity will then have, again, we're going to attach an animation and again, a status label. And then we're going to go to expressions. And we're going to name it, we're going to place the expression of destination node. And this will conclude our defining the entity. So now we're going to go on to defining a nodes list. To do this, it's going to be within the definitions window. And then we go down where it says on the left-hand side where it says list, we're going to click list. And then we're going to go to the create ribbon and hit node, because we want to create a node list. This node list is going to be named entity destination node list. And what this list is going to do is that we're going to, as nodes, we're going to have the inputs to sync. So then whenever an entity is in the source, when it's ready to leave the source, when it's in the node, this is the node that's going to determine where it goes after leaving the source. From here, we need another node. We need the same way we did this list of nodes. We need another list. So we're going to go to list and then node, and this list is going to be named entity source node list. From here, we are going to attach the outputs at source 1, outputs at source 2, and outputs at source 3. And this is going to be used in the process logic when the entity is waiting for the vehicle to pick it up as well. Now we go to now we're going to define the state integer. So we're going to go to the definitions tab, and we're going to click states. And under integer above, we are going to use this state variable, state integer variable, which will be named pickup request index. And this will be a pickup request for later on when we're using the truck fleet management logic. My teammate Diego will continue with the next part of the presentation.
So we're gonna keep working on the model. So right now what we're gonna work on is on the nodes. So as you guys know, and as Luis already mentioned, we can select all the nodes at the same time. So just press the Control key when selecting all these nodes, right? And then what we're gonna do is we're gonna, you can see this menu right here on the right side. We're gonna go to the entity destination and we're gonna change that. We're gonna change it to select from list. So now we're gonna have to fill in some blanks. So for example, for the node list name, we're gonna name it entity destination node list. Okay. Entity destination node list. And then for the selection rule, we're gonna change that as well. We're gonna change it to random. Can you see that? And then, so this, we're doing this because with this logic, the entities from any of the source objects may be moved to any of the sync objects because they're gonna be assigned randomly. So these are gonna be assigned randomly, but the same truck is gonna go to the same sync every time. But this is gonna be random, the source from where it comes from. Okay. So now that we have changed the nodes, what we have to do is, let me see, to this part where it says transport logic, we're also gonna have to change it to true. So this part, we changed it to true, and now we're gonna have to fill in some blanks as well. So for this part, which is the transporter name, we're gonna give it the name of truck. Okay. And then for this part, which doesn't have anything at the moment, which is the selection condition, we're gonna write the following: model entity dot assign truck, two equal signs, and then candidate dot vehicle. Okay, so that's what goes for the selection condition. And this basically is all we have to do for the nodes. This is what's gonna allow us to transfer our entities using the vehicles, but now we have to create some processes. So for that, we're gonna go to the process window. And instead of creating process as we usually do, we're gonna select this one, select process on run initialized. As you can see, here's like the first part of our process, but we're gonna have to add some of these steps right here. So the first step that we have to add, let me just quickly make sure that I have the right name. Okay, we're gonna have to add a step which is called search, this one right here. Okay, now we select the search, and then we're gonna have to change its information as well. So it says to change the collection type to node list. So instead of entity population, we're gonna change it to node list. Okay, now for the node list name, we're gonna have to select entity source node list. Okay, this is one of the lists that we previously created when Luis was explaining it. Entity source node list, and we're gonna change the limit to infinity. Okay, so this step is gonna provide a token related to each source in the list that will exit the found exit of the step. So now from this part where it says found, we're gonna have to add another step, which is subscribe. So we're gonna type for it. That way we can find it easier. So it's right here, subscribe. You're gonna drag it and you're gonna make sure to put it under the search step. Okay, so now we're gonna have to change the information for that as well. Let's go to event name. And for that, we're gonna do transfer node. And here's the tricky part, because we're not gonna follow the name that it's given on the tutorial. We have to change it to something else, which is writer waiting. That way we don't get any errors. We have to change that part. Okay. And then right now we're gonna get some errors because we haven't created what we will call the truck fleet management process, but it doesn't matter. So don't get worried about that. It's gonna change as soon as we create that process. So transfer node writer. Okay, we've changed that already. Remember, it's writer waiting. And then for the event condition, let me see what we have to put. Okay, so now we have to change the condition. We're gonna write this truck fleet management dot tokens in process dot number items to equal signs 0. Okay, that's for the event condition. As I told you, you're gonna get this error because we haven't created the truck fleet management process yet, but don't worry about that. And then we're gonna change the process name to truck fleet management. Okay, again, you're gonna get this error because we haven't created this process. So now we're gonna have to enter a second search step. So let's look for the search step here. It's a second search step next to the first one that we created. The collection type, we're gonna keep it the same as entity population, but we're gonna change the entity type to truck. Okay, and then we're gonna, the limit, like we did previously, we're gonna change it to infinity. There it is. Okay, so now that we have this new search step, we're gonna do something similar. We're gonna add another subscribe step. So let me just look for it. Subscribe. There it is. We're gonna add it here again under the search step. Okay, and then once we have it, we're gonna change the information again. So we're gonna go here. We're gonna change the event name to vehicle dot ride station dot exited. And then the event condition is gonna change to truck fleet management dot tokens in process dot number items to equal signs 0. Again, the same error because we haven't created that process yet. And then for the process name, we're gonna change it to truck fleet management. Okay, and that's it. Okay, so all these errors are gonna hopefully disappear once we create the following process, which is gonna be explained by Eric Barragan.
The next part is the process logic for truck fleet management process. We click on create process. And specify the name as truck fleet management. add a delay step and specify it as math.epsilon. Add a search step with a collection type of entity population. The entity truck type of truck. The condition of candidate.vehicle.resource 2 equal signs and a 0. Resource state 2 equal sign a 0. Add a decide step. Add a decide step. Specify the condition or as a global dot visit request queue dot number writing. Request queue dot number writing. This will determine if there is any entity waiting to be assigned a vehicle. From the true exit of the decide step, add a find step. And change the variable name to pickup request index. And the starting index should be 1. And the ending index should be global.visit request queue.number writing. The search expression should be math the search expression should be math dot if parenthesis vehicle dot population dot index 2 equal signs 1 comma global dot visit request queue dot item at index parentheses pickup request index parenthesis dot model entity dot destination node 2 equal signs input at sync 1 comma vehicle dot population dot index 2 equal signs 2 comma global dot visit request queue dot item at index parentheses pickup request index dot model entity dot destination node, two equal signs, input at sync 3. To global dot visit request queue dot item at index parenthesis pickup request index dot model entity dot destination node, two equal sign, input at sync 3. And place an assigned step. And don't forget to write the index variable name as pickup request index. And that is the assigned step. Set the variable name to global dot visit request queue dot item at index parenthesis pickup request index parenthesis dot model entity dot assign truck. This will assign the entity's transporter reference state. Add a planned visit. The new equal to the new value of the vehicle. Add a planned visit. Select the entity type to be specific object. Under advanced objects, select specify to specific object. An entity object to be vehicle. The planned visit step will cause the particular vehicle to search the global.visit request queue for any request.
So now we're gonna try to run the model to see if it works properly. So let's go back to facility. Let's try to run it. Okay. So as you can see, we have 3 trucks that are moving from one source to a sink. Let me see if I can adjust the speed so that you can maybe see it a little more clear. So for example, let's look at truck number 1. As you can see, truck number 1 is always going back to sync 1. So it doesn't matter where it takes the entities from, it goes to sync 1. Can you see? And then now let's look at truck number 2. It doesn't matter where it takes the entities from what source, it goes back to sync 2. And finally, truck 3, doesn't matter what source it comes from, it always goes to sync 3. So there's our model of our vehicle that's transporting different entities to different from different sources to different syncs. I hope you guys understood everything, and thanks for watching.